So, continuing on with our discussion on the topic of optics, let's now take a look at image formation using lenses. So, in the previous video, we looked at mirrors, image formation using mirrors. Let's now take a look at image formation using lenses. Now, lenses are optical devices that use refracted light to form images, as opposed to mirrors, which use reflected light to form images. So lenses, refraction is what is used to form the images. There are two types of lenses to speak of. We have the converging lens and the diverging lens. Regardless of whether you have a converging lens or a diverging lens, we use the same equations when it comes to analyzing the image formed. 1 over s plus 1 over s prime is equal to 1 over f is equal to 2 over r. F is just equal to r over 2. And then we have m is equal to negative s prime over s is equal to h prime over h. You're familiar with this set of equations because these same equations are what we have or what you saw when we covered image formation with mirrors in the previous video. Same set of equations for image formation with lenses. There are some differences, particularly in terms of the sign convention for our variables. S is still the object distance or location of the object with respect to the lens. And as usual, the object is typically in front of the lens, in front of the optical device, just like in mirrors. So typically S is positive if the object is in front of the lens, and negative if the object is somehow behind the lens. This is particularly applicable when you have a system with more than one optical device, say two lenses or one mirror and one lens and so on, wherein the image of one optical device will be the object of the other optical device, and said object of the second device will somehow be behind the device. So S may be negative in this regard. But as long as the object is in front of the lens, S is positive. S prime is still the image distance or location with respect to the optical device, in this case the lens. This time, we are talking about refracted light. The light passes through the lens, so the refracted light is behind the lens. The image that should be formed should be behind the lens. So S prime is positive if the image is found to be behind the lens. You have what is referred to as a real image. Negative if the image is in front of the lens and you have a virtual image. So if you recall the S prime for the mirror, it's the opposite. For the mirror, S prime is positive if the image is in front of the mirror, real image. And S prime is negative if the image is behind the mirror, virtual image. For lens, again, it's S prime is positive if the image is behind the lens, you have a real image, and S prime is negative if the image is in front of the lens, virtual image. F is still the focal length and R is still the radius of curvature. F is positive if the effective focal point is behind the lens. There are two focal points to speak of for lenses, And if one of them, the effective focal point, is behind the lens, f is positive for the lens. Focal length f is negative on the other hand if the effective focal point is in front of the lens. The same goes for the radius of curvature, the effective radius of curvature of the lens. For many lenses, there are two radii of curvature. One of them is the effective radius of curvature as far as image formation is concerned. And if the effective radius of curvature in is behind the lens, R is positive, and negative if the effective center point or radius of curvature is in front of the lens. M is still the lateral magnification, just like with mirrors. Again, M may be positive or negative depending on H prime. And the object height h is always positive. H prime is always with respect to the object height h. If the image has the same orientation as the object, h prime is positive. But if the image is inverted or upside down with respect to the object, h prime is negative. There are two types of lenses. As we have mentioned, you have the converging lens and you have the diverging lens. Let's take a look at the converging lens first. A converging lens focuses the incident light that is parallel to the center line. So the dashed line is the center line. The lens focuses the incident light towards the second focal point, F2. F2 is referred to as the effective focal point of the lens. So the effective focal point is behind the lens. Therefore, F is positive. The same goes for R. R is positive for a converging lens. And depending on the location of the object, the location of the image will change. You might have a virtual image or a real image. Diverging lens, on the other hand, the tendency is that it focuses the incident light that is parallel to the center line. It focuses the incident light away from the effective focal point F2. So this time the focal point, the effective focal point is in front of the lens. F is negative. The same goes for R, for radius of curvature R. R is negative, F is negative for a diverging lens. For a more complete picture on lenses, image formation with lenses, you might want to read up on the lens maker equation. The lens maker equation basically tells you how the focal length of an arbitrary lens is determined. So you might want to consider this as a reading assignment for a more complete picture of image formation with lenses. So that's it for now. In the next video, we'll take a look at the examples part of our discussion on optics. So thank you for watching.